Good morning, students. Welcome to another session of Bridge course. This is Dr. Sheikh Anwar from Department of Science and Humanities. So, in this session, we'll be talking about the topic batteries. We all know that without batteries, it is very difficult for our day-to-day life. So, in this topic, I am going to cover different aspects. So, following are the contents. So, I'll be talking about the introduction of the batteries. Then I'll be talking about the classification of the batteries, followed by the primary cell, the secondary cell, and finally the fuel cell. So, these are the contents which I will be dealing in this topic. Coming to the aim. So, by this video lecture, I would like to tell you the construction and working principle of any of the battery which we will be discussing in this lecture. And the expected outcome is, we will be trying to understand the different application of batteries. Coming to the introduction part. During these pandemic times, we should understand that we are supposed to gain the positive energy around us, not the negative part. As we know that the batteries have the positive terminal and the negative terminal, which will generate the electricity. It is also said that we can have the flowers blooming even on a thorny plant. So, it is very important that during this COVID times, we are supposed to share knowledge. Coming to the different kind of batteries. So, we have got batteries in different shapes and sizes, from the button cell, from the suitcase kind of thing, from this different kind of cylindrical shape. So, we have got different kind of shapes for batteries, and these batteries are used in our day-to-day life, starting from our wristwatch, starting from our pointer what I am using, starting from this calculator for the filly shave, and even for your mobile phones, the camera phones, the digicam, the laptop, all these require batteries. And apart from these, we also require for our electric motors, the UPS system, the telecom system, the security system, the medical system, as well as the data centers in storage power backups. So, this is what actually we are supposed to depend on these batteries in our day-to-day life. Coming to the history of battery. So, the battery was first coined by Benjamin Franklin in the year 1748. Later on, it was first made by Alessandro Volta in the year 1800. From 1800 to 2001, you can see the batteries have taken a great shape for its evolution. So, we can start actually with the lead acid battery, the nickel cadmium battery, then nickel metal hydride battery, and finally the lithium ion commercialized AO231 systems. And now we are going to silicon nanowires. And before this 1800, we have got a small incident by an Italian chemist Lucy Galvani. Lucy Galvani was the first person who tried to carry out an experiment on a dissected frog. So, he took out a dissected frog and connected the upper nerve with a copper wire, and he took out the lower limb and connected with a zinc wire. So, the moment he tried to connect the copper wire and the zinc wire, the frog had a kind of movement. So, he was incorrect in stating that electricity was coming from the tissue of the animals. It was later Alessandro Volta who stated correctly that this movement is because of the two electrodes, that is the copper electrode and the zinc electrode, and the body fluids of the frog are just mere an electrolyte. So, coming to the modern day electrochemical cell, we should know that the modern day electrochemical cell should have two electrodes, the anode part and the cathode part. Before I go into the details of this electrochemical cell, I should tell you a mnemonic. An ox, red cat. If you expand this mnemonic, we should know that oxidation always occurs at the anode, reduction always occurs at the cathode. So, with this, we are going to move our lecture. One thing you should try to ponder, that for an electrochemical cell, the anode is negative terminal and the cathode is a positive terminal. Why is it so? To understand that, let me show you a small PPT. Suppose we are having a metallic strip, zinc metallic strip dipped in zinc sulfate. Whenever we try to dip the zinc in zinc sulfate, zinc has more tendency to lose electrons. So when it has more tendency to lose electrons, the zinc ion comes out as Zn plus 2 and comes into the aqueous solution, and we are having the electrons at the periphery of the metallic strip. Since this metal has more tendency to lose electrons, it cannot lose electrons as is such. If at all I take another beaker and have another metal, and this metal has more tendency to accept electrons, and I try to connect using a connecting wire, now zinc, since it is having more tendency to lose electrons, it starts losing electrons to this metallic wire. So you can see the electrons, and this moving electrons we call it as electricity. So this phenomena was well explained by Alessandro Volta. And you should also know that for an electrolytic cell, the anode will be positive and the cathode will be negative. Let us try to differentiate between a galvanic cell and an electrochemical cell. In electrochemical cell, chemical energy is converted into electrical energy, and in an electrolytic cell, electrical energy is converted into chemical energy. So it is a reverse process. In a galvanic cell, the anode is a negative electrode and the cathode is a positive electrode. For an electrolytic cell, the anode is a positive electrode and the cathode is a negative electrode. And we also require a small salt bridge. And why this is required? Because whenever we are having more concentration of Zn plus 2 ions, the Zn plus 2 ions cannot be counterbalanced by the sulfate anions. To counterbalance this excess of zinc ions present in this solution, the salt bridge tries to release the Cl minus ions. So the role of the salt bridge is to maintain electric neutrality. So we can see that in an electrochemical cell, we are having two half cells. A half cell actually where the oxidation process occurs, and this half cell is called as the anode, and the other half cell where the reduction process occurs, and this half cell is called as the cathode. Let us try to have an understanding about the zinc copper galvanic cell. So we are having zinc anode dipped in zinc sulfate solution, the copper cathode dipped in copper sulfate solution, and these two compartments are connected through a salt bridge. And we can see that zinc has more tendency to lose electrons, so Zn is going to release 2 electrons to form Zn plus 2. So we are having more concentration of Zn plus 2 ions in the solution. And you can also see the deflection of the voltameter. The electrons, they start from the anodic compartment and they reach the cathodic compartment. At the cathodic compartment, the copper plus 2 ions which are present in the solution, they take up these 2 electrons to form copper solid. So eventually at the end of the day, we can see that the zinc metal is losing its mass and the copper metal is gaining its mass. So what is the role of salt bridge here? Whenever we are having more concentration of Zn plus 2 ions and less concentration of SO4 minus 2, then the salt bridge will maintain electric neutrality by releasing the Cl minus ions. In the other compartment, we are having less concentration of copper plus 2 ions. Why? Because copper plus 2 ions have taken the 2 electrons from the other compartment, that is the anodic compartment, to form copper solid. So we are having less concentration of copper plus 2 ions and more concentration of SO4 minus 2 ions. So again, the salt bridge will maintain electric neutrality by releasing K plus ions in the other compartment. So you can see a beautiful animation where zinc is losing 2 electrons and it is forming Zn plus 2, and here the salt bridge is maintaining electric neutrality by releasing Cl plus ions. In the other compartment, the copper plus 2 is taking the 2 electrons released from the anodic compartment to form copper solid, and again here the neutrality is maintained by releasing K plus ions. So we can say that in an electrochemical cell, we have got two compartments, the anodic compartment and the cathodic compartment. So the anodic compartment is the one which releases electrons, and the cathodic compartment is the one which accepts electrons. So you can see that the net reaction can be written in this form: Zn plus Zn solid, which is in the zero oxidation state, has undergone oxidation. So I can again repeat as an ox. So oxidation has occurred at the anode, and I can also say that reduction has occurred at the cathode. At the cathodic compartment, the copper plus 2 ions in the aqueous form has taken up the 2 electrons and form copper solid. So zinc is converting from 0 to plus 2, and copper is reducing from plus 2 to 0. Let us try to understand the working principle of a battery. For a battery, we are having two cycles. One is the discharge cycle, the other is the charging cycle. And during the discharge process, the cell is operating as a voltaic cell, and it is supplying electrical energy to the system. And during the charging process, we are trying to apply a DC current in the opposite direction, so that the products can be reversed back to the reactants. And this working principle of a discharging and a charging can be found out in most of the secondary cells. So based on the charging and the discharging process, I am going to classify the batteries. So for a primary battery, we are having only one cycle, that is the discharging cycle. So for a primary battery, we cannot have the reverse process where the products cannot be converted back to the reactants. For a secondary cell, we can have two processes, that is the discharging process followed by the charging process. So the reactants can be converted to products, and the products can be reversed back to the reactants. The other category of cell which we are going to discuss is the fuel cell. And this kind of batteries, they require a constant supply of fuel. And based on the discharging and the charging process, we are going to understand a few concepts of the primary, the secondary and the fuel cells. So the primary cell, it is acting as only a galvanic cell or a voltaic cell which produce only electricity by the discharging process. For a secondary cell, during the discharging process, it behaves as a galvanic cell, and for the reverse process, during the charging process, it behaves as a electrolytic cell consuming electricity. For a fuel cell, it is just a simple galvanic or a voltaic cell which produces electricity by consumption of fuel. For a primary cell, the reactions are not reversible. Okay, so we cannot convert the products back to reactants. For a secondary cell, the reactions can be reversible where the products can be converted back to reactants. For a fuel cell, the reactions can be made reversible, but this is found only in reversible fuel cells. That is a separate topic which it is out of the boundary of the engineering chemistry aspect. For a primary cell, it cannot be recharged, but for a secondary cell, it can be recharged, so that the products can be converted back to the reactants. For a fuel cell, we have to supply a constant fuel, so that the reactants can be converted to the products. Coming to the primary cell, it can be used as long as the active materials are present. When all the reactants have converted to products, we cannot generate electricity. This can be used again and again by doing the charging process. So we can have the discharging cycle followed by the charging cycle, so on and so forth. We can do the process. The Leclanc cell is one of the category of the primary cell. For a secondary cell, we can have the lead storage battery or the lithium ion battery, and recently the nickel cadmium battery. Hydrogen oxygen fuel cell is one of the important fuel cell which is used in spacecrafts. Apart from hydrogen oxygen fuel cell, we can have another fuel cell called as the methanol oxygen fuel cell. So for a primary cell, they are basically used in transistors and radios. And for a secondary cell, they are used in digital cameras, automobile equipments, laptops as well as flashlights. So, for hydrogen oxygen fuel cell, they are mostly used by space shuttles. Coming to the next topic, primary cell. Let us try to understand the basic construction of a primary cell. So, we have got a zinc case which is negatively charged, that means it is a anode, because we know that zinc has more tendency to lose electrons to form Zn plus 2. And we are having a carbon rod. Surrounding the carbon rod, we are having manganese dioxide, that is MnO2. And surrounding this manganese dioxide, we are having electrolytes such as ammonium chloride and zinc chloride. So, you can see that this metal bottom is anode, which is negatively charged, and we are having the metal cap which is positive charge, that is the cathode, and this carbon rod is surrounded by manganese dioxide and a moist phase of ammonium chloride and zinc chloride. So, let us try to understand the basic reaction. Zinc, which is in the zero oxygen state, will lose electrons to form Zn plus 2. So, I can say that oxidation actually reactions occurs at the anode. In the reduction reaction, we can see that these two electrons are taken by manganese dioxide. We should know that manganese is in plus 4 oxygen state. So, this manganese is converting to plus 3 by just balancing of this equation. So, these are the two basic reactions occurring in a primary cell. The role of carbon rod is to just allow the flow of electrons and increase the electrical conductivity of manganese dioxide and retain the moisture of the electrolyte. Let us go to the secondary cell. In a secondary cell, we are having two cycles. One is the discharging cycle, the second one is the charging cycle. Let us try to talk about the lead acid battery. In a lead acid battery, we are having two electrodes. The first electrode is Pb, that is lead. The other electrode is PbO2, lead and lead dioxide. Pb acts as a anode, which is negative, and PbO2 it acts as a cathode, which is positive. So, we should know that the flow of the current is from the anode to the cathode, which is given by the deflection of this voltmeter. So, Pb, which is in the zero oxygen state, will lose electrons to form Pb plus 2. And these two electrons are taken by PbO2. We should know that PbO2 is in plus 4 oxygen state. So, this PbO2 undergoes reduction to form Pb plus 2. We should also know that the electrolyte used is 21% of sulfuric acid. So, in this reaction, we are having the 4H plus ion resulting in 2 molecules of water. So, this reaction occurs at the anode, the oxidation reaction, and this reaction occurs at the cathode, which is a reduction reaction. So, you can see very clearly that Pb has raised its oxygen state from 0 to plus 2, and PbO2 has reduced from plus 4 to plus 2. Once this discharging cycle is about to complete, this PbO2 reacts with SO4-2. From where this SO4-2 is coming? It is coming from the electrolyte. This SO4-2 will react with Pb plus 2 to form PbSO4 at the anodic compartment. Similarly, at the cathodic compartment, the Pb plus 2 again will react with another molecule of SO4 minus 2 to form another molecule of PbSO4. And you can see here very clearly PbO2 has just taken H plus ions and SO4 minus 2 ions to form PbSO4. So, we can say that since the concentration of SO4 minus 2 ions are decreasing, the discharging cycle involves the reduction in the concentration of the sulfuric acid. The net reaction during discharging cycle is Pb and PbO2 in presence of 4 H plus ions and 2 SO4 minus ions will give PbSO4. I am trying to indicate an arrow which shows that PbSO4 is deposited at the respective electrode, releasing an energy of 2.1 volts. So, during the discharging cycle, we are releasing an energy of 2.1 volts. And we are going to see during the charging process, we should require an amount of energy greater than 2.1 volts to do the reverse process. So, during the charging process, two molecules of PbSO4 have to break down to Pb and PbO2 with energy greater than 2.1 volts. So, we can see in this reaction H plus ions and SO4 minus ions are released. So, I can say that during the discharging process, the concentration of sulfuric acid is decreasing, and during the charging process, the concentration of sulfuric acid is increasing. So, and I should also tell that during the charging process, the lead acid battery is behaving as a electrolytic cell. So, the anode will be positive and the cathode will be negative. So, this is the animation where I can show you that Pb has converted to PbSO4 and similarly PbO2 also has converted to PbSO4. So, PbO2 and Pb have converted to two molecules of PbSO4, releasing an amount of 2.1 volts. So, in the reverse process, we can see that this PbSO4 is converted back to Pb and PbO2. So, whether it is a discharging cycle or a charging cycle, we should understand that oxidation always occurs at the anode and reduction always occurs at the cathode. Let us go to the next secondary cell, that is the lithium ion battery, and try to understand how does this lithium ion battery works. For lithium ion battery, we have got two processes. One is the insertion process, which we called as intercalation. The other is the extraction process, which we called as deintercalation. So, this kind of phenomena of deintercalation and intercalation is seen in a lithium ion battery. We are having the anode, that is the intercalated graphite. So, we are having the C6, that is the graphite, which is a honeycomb like structure, and in between these honeycomb structures we are having the lithium atoms, and these lithium atoms will lose one electron, and this electron can be seen flowing through the external circuit. And during the discharging process, these lithium ions will migrate to the other compartment. So, we can see that there is a deintercalation of lithium ions from the anodic compartment, and the lithium ions are migrating to the cathodic compartment. At the cathodic compartment, we are having a lithium cobalt oxide. So, we can see that the cobalt is in +4 oxidation state. This electron will reduce the oxidation state of the cobalt from +4 to +3. This is what the discharging process which we can see. So, we are having the graphite, and this graphite is having the lithium atoms. These lithium atoms, they are releasing slowly one electron, and you can see once they have reached one electron, they have become Li plus and they are passing through the other compartment through this separator. This separator will allow only Li plus to pass from anodic compartment to the cathodic compartment. So, at the cathodic compartment, we can see the electrons are being taken by the cobalt, and they reduce from +4 to +3. Let us try to understand the charging cycle. So during the charging process, we should know that the cathode which is having Li plus will try to release to the anodic compartment, and you can see the movement of the lithium ions from the cathodic compartment to the anodic compartment. And since it is a charging process, we are trying to apply an external current in the opposite direction. So it is going to release back the electron. Now during this process, the Li plus is again converted back to Li. So in this way, this discharging process is accompanied by the charging process. As a result, the lithium ion is getting back to lithium atom. So this charging and discharging process will be seen in the lithium ion battery. Let us try to look out the reaction. So we are having LiNC, n number of lithium atoms is going to form n number of lithium ions. It is also going to release n number of electrons. At the cathodic compartment, these n number of electrons, they are going to be taken by the cobalt. So we are having the formation of LiCoO2. So this discharging and charging process can be done multiple times. So you can see here we are having the intercalated graphite, and these lithium atoms, they just release the electrons from the outer circuit, and the discharging process is trying to consume the power. And during the charging process, we can see the battery is connected to the external circuit, so it is trying to release back the lithium ions to the anodic compartment. So this deintercalation and intercalation phenomena is observed in the lithium ion battery. Let us try to look out the last section, that is the fuel cell. For a fuel cell, we definitely require fuel, and we also require oxygen, because without oxygen a fuel cannot be oxidized. And during this oxidation process, it releases energy in the form of electricity. So for a fuel cell, we definitely require a constant supply of fuel, where the chemical energy is converted into electrical energy. Let us try to understand the common fuel cell, that is the hydrogen oxygen fuel cell. So we are having the anodic compartment where there is a flow of hydrogen gas, and this at the anodic compartment, this H2 is oxidized to form H+. We have the hydrogen molecule giving 2 H+ ions plus 2 electrons, and you can see these 2 electrons are flowing through the external circuit, and they migrate to the cathodic compartment. And this cathodic compartment will accept the electrons, and the O2 is converted to H2O. So we can see here the hydrogen are represented by red balls, and they just actually convert to H+ ions, and they pass through the proton exchange membrane. And this proton exchange membrane will allow only H+ ions to pass through it, and the electrons can be seen flowing through the external circuit, which are represented by the yellow balls. And these electrons are taken by the oxygen atoms in presence of the H+ ions to form water. So this is the reaction, anodic reaction. We can see here 2H2 is converted into 4 H+ ions with the release of 4 electrons, and these 4 electrons are taken by oxygen at the cathodic compartment. So we are having a simple overall reaction, 2H2 plus O2 plus 2H2O with the release of energy. And this fuel cells are used by space shuttles, and this water is a source of fresh water for astronauts for their space explorations. This is what actually we have come to the conclusion. So in this video lecture, we have differentiated what is an electrochemical cell and what is a electrolytic cell. So for an electrochemical cell, we can have 2 compartments, the anodic compartment and the cathodic compartment. In the anodic compartment, oxidation occurs, and in the cathodic compartment, reduction occurs. So the only difference is that for an anode it will be negative, for a cathode it will be positive. The reverse is found in a electrolytic cell. We also differentiate between a primary cell and a secondary cell. In a primary cell, we have got only one cycle, that is the discharging cycle. For a secondary cell, we have got two cycles. One is the discharging cycle, the other is the charging cycle. And finally, in fuel cell, we should know that we require a constant supply of fuel for generation of electricity. And we have taken the applications of the primary cell, the secondary cell and the fuel cell in this video lecture. So that's all actually from me. So I am thankful for your kind patience, and if at all you have got any doubts, you can email me, or you can just actually put me a WhatsApp actually on this number. Till then, take care.